Alright, so here's video 2.2. It's how to write an absolute value equation based off of a graph given to you. Alright, so we have this equation up here, and we're basically just going to fill in this equation with A, H, and K. Don't actually copy down the negative. The negative will take care of itself, so we'll kind of ignore that and we'll get back to that later. So first we have to identify the vertex, or HK. So in this case my vertex is 1, 4. The x value of my vertex is H. The y value of my vertex is K. So when I start writing my equation and fill in H and K, I just need to know my vertex location. So I don't know what A is, so A is going to stay the same. I'm going to plug in 1 for H and 4 for K because that's the HK on my vertex. So what I got in my vertex just gets plugged in for H and K in that generic equation that I highlighted up there. Alright, now to actually solve for A. So to actually solve for A, we need to pick another point on the graph. So just pick any point you like. I'll pick this one. And that point is 2, 6.
Is it bad that I have...
Okay, sorry if my sentence cuts off there. Teacher walked in, so sorry. Alright, so we're back to solving for A. So to solve for A, we need to find another point, and I picked 2, 6. Doesn't matter what point you pick, we're going to get to the same spot. So the 6 is going to be plugged in for my y value. The 2 is going to be plugged in for my x. So I'm going to copy down this light blue equation. But instead of f of x, I'm going to put a 6. And instead of x, I'm going to put a 2. I'm replacing my values with those. Now, we just need to solve for A. So 2 minus 1 is 1. The absolute value of 1 times A is just A. And then subtract 4. And I'm out of room, so I got to write it up here. But so we get that A equals 2. Now to actually finish my equation, I'm going to copy down that equation at the beginning.
Pardon this interruption. This is a reminder, teachers and students, please release all of the band members to go to the calling game at 3:30 today. All the band members. Thank you.
Okay, so we're going to copy down the equation, and we're going to plug in our A, our H, and our K. So when we're doing this, you solve H and K comes from the vertex. We solve for A using another point on the graph, and then we put it all together, A, H, and K, to finish. Real quick, I want to do this one just to show you another A value. So we have -2, -1. So my H and K, and I'll go ahead and get my other point. My other point is -1, -4. So when we actually write this out, I have f of x. Again, I don't know A. Here I have x minus -2 when I plug in for H. So minus -2 turns into +2. My other point is -4, -1. And when I actually solve for A, I get A to be -3. So when I plug it all in, I get -3 x plus 2 minus 1. Now the reason I'm showing you this one is because an A of a -2, an A of a -3, a negative out front in transformation form, if we remember, means that the graph has been reflected over the x-axis. A normal absolute value graph looks like a V, so if I reflect it, it should look upside down, which this graph does, so a negative A value makes sense. If your graph shouldn't be reflected and you get a negative, that should be your red flag that it's incorrect. But since this red graph has been reflected, negative A is okay.